So today we're going to be using this RFID reader and reading the data inside this RFID, which is in the backside of this piano. Let's get started. So in this video we're going to take a look at trying to get data out of a DTI515 or DTI516 RFID reader. Now this tutorial theoretically should work for any of the RFID readers in the DTI range from IFM. So I also have here a DTI513, which is a larger IO-Link RFID reader, but at the moment I'm going to be using this physical one. Perhaps towards the end we will swap out the RFID reader and see if it makes a difference, but that's what we're going to start with. So for this tutorial we're going to be taking a look mainly at the data sheets and also some of the example programs given by the IFM. We're going to be downloading them, using them, and seeing how we might be able to use them in our project. So the actual website itself has quite a good download section, and we can see that there's a couple of things here that are useful for us. I'm going to be using a Siemens PLC today, and we see that we actually already have here an example Siemens program. We're going to look at this in a moment, and if we scroll down as well we should get the IODD files. So we'll start by just downloading the IODD files. I already have it downloaded, but there we go. And we are also going to download the Siemens example program, which I have also already downloaded, but we'll download it again here so that we have a copy of it. So let's take a little look here at these files. If we come into my downloads folder, we will start just by taking a look at the IO-Link Siemens example. This is what we have here. And so the Siemens example that we've been given contains a couple of different things. The first thing it does is it has some parameters for their AL1 devices. These are the IFM IO-Link masters. We're not going to be using that today because we're going to be using an ET200 SP PLC instead. So we're going to take a look at this one, which is the 1200-1500 version. And if we open this up here, we see that there is a version 14 project that we're going to be able to use. So if we come into a version of TIA and we try to open up the version 14 project, so if I just come into my downloads here and open up this version 14 project, what it will probably try and do is it will try and upgrade it to a version 20 project. That has happened for me already, so rather than getting it to do this twice, I'll just see if I can find the upgraded project. I should have it saved. Let's just go up and see if it's there. There we go, V20, here we go. So I'm going to open up just this project here so that we can take a look at it, and we'll just wait for that to open. So this is exactly the same project that was downloaded from the IFM website, it's just that it's been upgraded to a later version of TIA Portal. Great, here we go. Okay, so now that the program has opened, we can open up the PLC and take a little look at what's happening here. So in our program blocks folder, we should have here a main function. And inside it, we can see that there's the special function block, DTI513, and then we have here some little kind of helper functions that will allow us to read and write this data from the tags, but really the function block is the only thing that is going to be useful here for us. I don't want to migrate the whole project across, I just want the block, and I'm going to do everything else myself. So I'm going to come across to libraries here, and what we're going to do is take a look at the project library, and in the project library we can see here the DTI block. This is the same one that we have here, and so I'm going to create a new global library which I'm going to call my RFID lib. And I'm going to move the function block over from the project library into the, I think I should just be able to put it here. There we go, into my RFID lib. Perfect, there we go. So now it's in there and we should be able to use it from other versions of TIA Portal. So if I jump out of this version of TIA and I jump into here and I open up, I have a blank project set up here ready to go. So this is a blank project that just contains my PLC configuration. So we can see here I have my ET200. What I should be able to do now is come across to libraries And if we see here, we should be able to open a global library. I should be able to find my RFID lib from here, open it. Oh, okay, it's already open in another project. That's because it's open here. So let's just jump out of here. Do I want to save changes to the library? Yes. Okay, let's see if we can open it now. There we go, in it comes, and here is the DTI function block that we've exported. So in my main, I'm going to come across here and I am going to drag this library in. Perfect, and now we are ready to start reading and writing data from my RFID. So the first thing I'm going to need to do is look at these properties that we have down here on the left hand side. Now again, we are going to reference heavily here the datasheet, and helpfully this datasheet is really good. I love IFM datasheets. They're incredibly easy to read. They make everything very easy, and they also have pictures of everything, which is great. So let's put this side by side with our real function block, and we can talk about what it is we are able to see here. So the first thing we have here is the hardware identifier. So the hardware identifier describes where this physical device is plugged into the PLC. Now, if you were using a remote I/O master or one of the I/O link masters, we would have to specify something here. But as we're using the built-in ET200 I/O link master, we don't need to specify anything at all. We can just leave this as 0. We're then going to need to specify things like input and output addresses. This is where the data starts on the PLC. We'll come back to this later. We then have a Boolean, which will cause an execute. We have a mode, which triggers whether or not it should be reading the ID or the user memory, writing, reading, writing. Basically, whatever we want to do here, we have to set the mode. And then we have the amount of data we want to read and write. This is from the user area. And then also we have the write data and read data buffers themselves, as well as some done, busy, and error signals that we need here. So how would we go about setting this up? What we're going to do is we're going to start by creating a new block, which I'm going to call a data block. And I'm just going to call this RFID data. And inside this, I'm going to create RFID1, which is going to be a struct. Now you could probably do this with like a variable or a user data type. I'm going to build everything as a struct here just to make life easier. And so what I'm going to want to do is to basically put in the bits of data that I'm going to need to change here or get the outputs of. So just to make my life easier, I'm going to prefix the ones on the left hand side with an I because they're sort of inputs to the block, and I'm going to prefix the ones on the outside with Q just because they're sort of outputs from the block. So we're going to have I execute. Yep, I execute. This is going to be a Boolean. The next one we're going to need is my I mode. This is going to be an integer. We then have our tag memory address. I'm pretty sure this is optional. I think we really are not going to use it at all because we're just going to start reading from 0 here, so I'll ignore this at the moment, but I do want length. I think length is going to be important here. So we will have I length, and then we need to have our write data and our read data. So we're going to have our I WR data, and this is going to be an array of bytes, and we're going to want 15 bytes. Now, the previous example read and wrote 1,000 bytes. We could have a huge amount of bytes here. Just so that I can fit everything in one screen, I'm literally just going to be reading 0 to 15. So that's, 16 bytes, essentially 1 word worth of data. And we're going to do the same here for my I read data. Perfect. So they should bring up the next. So then we have the indicators on the right-hand side of the block. So this is going to be my Q tag present, which is going to be bool. I spelled that wrong, but let's see here. Present. We're going to have our Q done. We're going to have our Q busy and Q error, which is an integer, and then we have our status as well. Q status, which is an integer. that should be everything that we need here. That should be good. So if we just put this side by side with our block, we can start to drag things across. So if we take here our execute, we take our mode, we take our length, we take our write data, and we take our read data, and then we take our tag present, our done, busy, error, maybe error is a boolean, let's see, and status, yeah, okay, so the error should have been a boolean, that's my fault, there we go. So that fixes that. So we now have everything set up in order to test our RFID, but of course at the moment it won't work because we have no idea where this RFID reader is attached. Now because we're using the inbuilt IO-Link master, what we're going to do is set that up within the PCT tool. So we open up the PCT tool here. There we go. And we are going to, well, we could either, if we didn't already have the IODD for this, we would import the IODD, we would browse, we would find the IODD that we had already downloaded, which is here for me. This will be the IODD files. I already have them imported, so I can just search for them here in my list here. We have it, and it is 515, actually 516, the version that I have on my desk here. So we'll take 516, drag it into slot 1, and we just need to know where this data is actually starting. So if I click on show PLC addresses here, I can see that it's set up to start from 2, and 2 for both input and output, and it's reading 32 bytes worth of data. But all I need to know here is this 222. So I'm going to download this setup into my PLC, so my PLC is happy that we are using this particular device. Hopefully all should be well, because I already had this connected before and didn't have any issues. Just wait for it to download here. Perfect, there we go. So that's all good. We can close out of PCT tool. We can come back to our main, and we need to set the DTI input address and output address. This is what we need to set to, because that's what we read from PCT tool, right? This is the byte where it's essentially mounted this RFID reader. So with that being said, we should now be able to compile everything. Okay, it does not like that because my RFID data block isn't compiled. So I only had main selected there. I'm going to click at the top here, compile. There we go, much better. Everything compiled. And now we can download. And hopefully what we can do now is if I pull up the RFID data at the same time, there we go, then we should be able to monitor in both of these windows and begin to see what's going on. Here we go. So let's just move this over to one side so we can see everything clearly. And I'm also going to maximize my read data and write data, so we should be able to see everything on the screen here at one point in time. So the first thing to do is test whether or not we actually see something. So I'm looking here at the tag present signal that we've got here, and I'm just going to hold up the RFID reader so you can see, and I'm going to hold up this little guitar as well. So this guitar has an RFID chip on the back of it, and if I press the guitar against the RFID reader, there we go, we see the tag present signal changes. So we see that it goes true. But we're not getting any data yet because we don't have any mode set up at all. So what I'm going to do here is I'm going to set the RFID reader mode to 1, and I'm going to turn on the execute bit. And so now it should be reading constantly, and so if I put the RFID in front of it again, it should, there we go, update, and you should be able to see on the read data, we see that first byte worth of data changes. So you see 3A, 5A on the byte number 6 and byte number 7 there, and that shows that we have here the guitar. And if I pick up this small piano that also has an RFID tag on the back and put it in there, then we see, there we go, the two different RFID chips working. Perfect. Okay, so this is good. We're able to read the UID. Let's take a look at reading and writing data. And how did I know that it was mode 1? Well, luckily this datasheet is really, really good. As I said, it's very easy to read through. And so all we need to do is scroll down until we get to these different modes. I can't remember exactly where it is in the datasheet. Let's just see. Oh, yeah, of course. Sorry, it's just here, exactly where we were. So mode 1 was reading the UID. Now, what we want to try next is writing data and reading data. Ideally, we could read it first, but at the moment these RFIDs are blank, so we can't read anything, so we have to write something to it first. So let's try and write something. So in my write data buffer, I'm going to update this so that we have A, B, and C in the write data buffer. And so I've got there 3 bytes worth of data. And so what I'm going to do here is change the length to be 3. I'm going to change the mode here to be 3. And I'm just going to... Actually, I don't think I want it to do it automatically. I think I only want to do it one time. So this is going to be write data to the RFID tag one time. So this is 4. I'm going to want to use actually 5. Sorry, 5 for write. So we enable 5 here, and then what I'm going to do is to turn off the execute. I'm going to take my RFID. I'm going to put my guitar next to my RFID, and then I'm going to execute. Perfect. So we got done here going true. That means it happened successfully. And so now if I switch it to mode 4, which is to read, at the moment we see in my read data buffer, these 3 here, they're all zeros, right? And now as soon as I read this data, I should get ABC appearing here because it will be reading it from the RFID. So we click it, and there we go. We got ABC being read. And we can prove that this wasn't a fluke if we drop the guitar and we pick up the piano, and then we try and do a read on that. It goes back to 0 because there's no data on the piano. And if we put the guitar back and then we cycle this again, so we read it again, there we go. And now we get ABC coming back because we have the data on the guitar. So hopefully this is a good introduction to show you how you are able to really easily use these RFID readers from IFM. I think they're really nice little readers, very small, very compact, very easy to use. Okay, and just a quick sidebar before we finish. I tested the project also with the larger of the RFID readers, and I can confirm that it works in exactly the same way. So we now have 2 RFID readers set up in this project, and they're both in automatic read mode for the UID. And so we can see the original one here at the top, RFID 1, and the new one here, RFID 2. So if I take my guitar and place it over the original reader, then we should see the data on the top one change. There we go, we see it change perfectly. And then if I move it across to the new one, we see the data appear on the second one. And so we have an absolutely perfect version working across multiple types of RFID reader. And that's it. I hope you found this video useful. Please feel free to like and subscribe for more content coming soon.